Hi, I'm Anna Hoffman, and welcome to this session. I thought I'd start with the sponsor and thank you slides because sometimes I forget to include them at the end. So I want to start off by really just thanking DPS and thanking all that you do for the community. Wanted to mention the 3 ways to win prizes. So post your selfie with the hashtag DPS 2021. You should go look for mine. Hopefully I've posted it by the time you're watching this, and give session and conference feedback. It's really useful for me. It's also useful for conference organizers to understand what you liked, didn't like, and if you should have sessions like this again. And don't forget to follow the DPS team on Twitter at those two URLs or Twitter handles. So with all that being said, I want to get started with this session for today. It's called Build Serverless Full Stack Applications in Azure, and that URL is the link to the learning path. So my name is Anna Hoffman, and I'm a program manager on the Microsoft Azure Data team. And I'm going to tell you a little bit about the learning path, and then we'll go right into the session. So this is a new learning path, a relatively new learning path that came out a few months ago. Myself and a colleague, Davide Mauri, worked on this learning path. It has 4 modules. You can see each of those modules on the screen, and you can also see, if I flip over to here, you'll be able to see the learning path here on Microsoft Learn. And one of the great things about this is that in each of these there are exercises, and those exercises include a free hands-on sandbox environment. So you can deploy Azure resources for free in 4-hour chunks. So there's 4 modules here. I hope you'll check them out. And really what we're trying to do is show you how to build modern apps using Azure services. And these services include Azure SQL Database, Azure Functions, Azure Logic Apps, Azure Static Web Apps, and even things like GitHub and Azure DevOps. So lots to learn. Hopefully you'll learn some new things and you'll go get hands-on with these things in Visual Studio Code and Azure Data Studio. Now I want to come back and tell you a little backstory about the scenario behind this whole learning path. So I was chatting with Davide, and he says, you know, I always have to catch the bus, right? And typically there's one of 2 things that happens when I try to catch the bus to go to the office. Now, the first thing that happens is I get to the bus stop early and I have to wait, and then the bus comes and I take the bus to work. What also happens more often than not is I get to the bus, but I see the bus. I didn't know it was almost here. So I see the bus. I have to run to the bus. And then, I miss the bus maybe, and I have to wait for the next bus and take it to get to work. This is not the ideal scenario. So let's look at the alternative scenario. So we all have cell phones, or a lot of people have cell phones these days. So wouldn't it be great if I could use my cell phone to look on a map where buses relevant to me were close by, and then I could walk leisurely to the bus stop when it got close. Maybe I get a notification when it was close, and then I could go ahead and head to the office. This is a much better scenario. So this is kind of what the learning path aims to address. So we'll talk first about the foundation for modern apps using Azure SQL Database. We'll talk about the serverless side of things and some things that play into that. And then we'll talk about the application itself. And then we'll finally conclude by talking about how you can use GitHub and GitHub Actions to do all of this automatically when you push changes. So that being said, we're going to go in order. We're going to start by creating a foundation for modern apps. Now, for each section, what you'll see I'm going to do is I'm going to start with the requirements and then get into the things specific to that service. So for this one, we're going to select a database service, but our all up requirements are: we want a website for monitoring the real-time bus locations, we want notifications when a bus is close by, and we want deployment automations. That's potentially where GitHub's going to play in. Now, when we think about the available data, we have 2 main data sources. The main data source really is a JSON file. Now, this JSON file contains the real-time information about different vehicles or different buses, where they're located, and their stop sequence, the timestamp, and all sorts of other information. So we know that the data exists to track these buses. It even includes like the route, so we can track only specific routes, which might be useful. And then the second piece of information that we have is the route data. So All of the routes that you saw in the real-time data, we also have kind of put together and what those routes are called and where they go and that sort of thing. All right, so those are our available data. Now, when we go to pick a database service or for any application, there are some modern database requirements, right? So we're hearing a ton about serverless in the space. We really, as a consumers, want to pay for only what we use, only when we use it, and we don't want to pay to just have idle servers sitting by. We also want to be able to support our development workflows. We want to, especially for this scenario, support JSON data because that's the format of our real-time data. And we also want to be able to support geospatial queries because in this case, we're going to be dealing with the location of different buses, the location of geofences, which we'll talk more about. And we don't want to have to use a bunch of different extra libraries if we don't have to. It'd be great if we could just do all that with the database service we select. And finally, we want to super-proof or future-proof. We also want to super-proof, but we want to future-proof our applications. And for those reasons, I think Azure SQL is going to be the best solution. And specifically, I think Azure SQL Database is going to be best for this sort of modern application. And a few of these things I'm sure you all are familiar with, but versionless is a big one. No one wants to deal with upgrades for their new apps or their cloud native application. You just want to be kept on the latest and greatest software. You also want things like native geospatial support for this scenario, which Azure SQL Database supports. We have a great developer experience with integrations in Visual Studio Code and Azure Data Studio. And we have support for serverless. So that's going to support our pay only for what you need when you need it. And if you grow really, really big, so if this app really takes off, you can even go to a hyperscale database, which is going to allow you to basically get limitless scale. And while we're seeing a lot of organizations and trends go towards NoSQL, at the end of the day, we think the relational engine is the backbone of everything. So as we invest as a team in things like JSON, which we support, geospatial, graph, key value, even XML, what you'll see is you're going to be future-proofing yourself because we're going to modernize the database. We're going to modernize the way you think about relational as we go forward with relational kind of being the backbone. So just a few things to keep in mind, my brief pitch to you for Azure SQL Database, but let's dive into some of those details. The first one is JSON. So Azure SQL Database does support JSON. You can see some of the built-in functions that are available, but basically what we're able to do is take a table like you see, or sorry, take some JSON data like you see there, and turn it into a table. And so then you can get all of the benefits out of tables. You can use something called OpenJSON to do that. And then you can use the T-SQL for JSON to format your results into JSON text. This can be really useful when you're trying to return results from, say, an API call. You can specify actually how that JSON data is returned. So JSON is supported, and I have a demo which I can show you more about that soon. Then the final thing I wanted to show you before the demo is that we do support spatial. This is just a screenshot from something in the demo. So let's go ahead and get right into the demo. Okay, so the first thing I want to do is I want to go back to this learning path, and I want to show you all, if you see in the first module, the first exercise is going to take you through configuring your development environment with Visual Studio Code. So we're going to take you through all the extensions that we think you should install for working with this project and also working with new applications. And then what you're going to do in the next exercise is you'll actually deploy and configure Azure SQL Database. And you can see you can activate a sandbox for this, which will allow you to do this for free. Now, what you can see here is it's going to deploy the database using PowerShell. I'm actually not going to step through this just because it does take a few minutes to complete, but we're basically completing a serverless database. You can see that here with a minimum capacity of 0.5 vCores and a maximum capacity of 4 vCores. Now, since it takes a few minutes to complete, I did mention I went ahead and deployed this. So you can see my bus database here, and you can also see that it is serverless. And we can see the auto pause delay has been set to 1 hour. So I can actually click into that. And what you're going to see is the options that I have for compute and storage. Now here you can see we're using the serverless model. So we're auto scaling between the minimum and maximum. So I have my minimum and my maximum set here, and we'll auto scale between whatever it is that you need in that range. And we're going to bill you on a per second basis for what you actually use. Now you can optionally enable auto pause delay. Now what this means is for this scenario, I'm not assuming people are using this application all the time. I'm guessing there are hours of the night or maybe even during the workday where people aren't trying to catch the bus. So during that time of no activity, no people trying to connect to the Azure SQL database, we can enable a pause delay of 1 hour. Now during this pause time, essentially we separate the compute from the storage at that point, and SQL Server essentially shuts it down. So during that time, you're only going to pay for the storage, which is really going to help in saving you quite a bunch of costs when you're not using the database. So this is the serverless database. And like I said, if you take a look at the metrics, because this is something I've kind of been using, you can see that I haven't touched this database in a few months, actually. So this is the app CPU I'm actually being billed for. And you can see that when I'm not using the database, I'm not being billed for compute. So huge cost savings, great for a demo environment, great for dev tests, great when you don't know what the connectivity or what the scale is going to be, because it can scale on a per second basis to what you need. All right, so then the next thing I wanted to show you is we actually wanted to configure this database. So when you go through the exercises, which I really hope that you'll do, in them there are some notebooks. So if you haven't seen notebooks, this is Azure Data Studio. I have some SQL notebooks, which basically combines text cells with runnable code cells. So you can see some of the SQL code cells that I have here, but there are also other languages supported here. Okay, so in this notebook, which I'm not going to go through in too much detail, what we're going to do is we're going to get the bus route data from that flat file. Remember, I told you the route data is in a flat file, but then the real-time data is in a JSON document. So essentially, we're going to create a table to store that route information. And then we're going to leverage a shared access signature, or an SIS token, to basically bring the data that is stored in an Azure Blob storage account into Azure SQL database. But there we're just granting access. We're creating an external data source to that storage account. And then we're just going to go ahead and insert the data from that routes.txt file. And you can see, for example, this is an example of one of the routes that we have. This is actually the route we're going to track, 100113 at Crossroads. So this is in Seattle. Then this will go through creating some necessary tables. But one other option that you have is to actually use GitHub Actions. So if I head over to GitHub Actions, what you can see here is an example of one of those actions. And this is the Azure SQL Database action. And it's essentially going to look for the DACPack file. So we can see it's connecting to the Azure SQL Database server. It's located the DACPack file, which you can find here. So that contains all the schema related to this database that's required. And it's going to go ahead and update the database and let us know that the update has completed. Now, in order for this to happen, it's very simple. What you use is a YAML file or a YML file. And that file essentially serves as instructions as to how to build this database. So anytime a push is made to the main branch or there's a pull request, go ahead and spin up this SQL action. And the SQL action is really just the Azure SQL action, and it connects to the database server, and it uses the connection string stored securely in the repository, and it looks for the DACPack file. In the settings section, you can see that I do have this secret stored here for my Azure SQL connection string, and that way you're not storing your secrets in plain text. Definitely not what you want to do. Okay, so we figured out how to update our database. So now when we update the database, we can update the DACPack file, and that will update our database or any future deployments of this database. Now, the final thing I wanted to show you is the geospatial support that you might remember me mentioning. Now, in the second notebook that you'll look at, what we have is we're going to look at some of those modern database capabilities. So I'm just going to go ahead and reset the demo. Let me connect to the database. Probably should have done that in advance. Let's see, it's 197. me just grab it. 60. Okay, so right now we're connecting to that Azure SQL database, serverless database you saw in the portal earlier, and we're just going to be able to work through the notebook. I'm just resetting the scenario. Now, the first thing we're going to do is we're going to look at an example payload. So this might look familiar. This is just a section that I brought out of that real-time JSON data that we're going to pull in eventually. But we're bringing in some of that, and I'm able to use OpenJSON to bring in that database and basically store it as a table. And one other thing to notice is with the geospatial support, I'm using geography point to take in the latitude and longitude and then specify the standard that we're using. And then we're able to kind of display that. So you can see this is the location that's coming through. And you're also able to see some different information that came from the JSON and is now in table format. Now, this location is interesting. It combines the latitude and longitude, but if we wanted to see that latitude and longitude again, we can use this verbiage of toString. So you can see if I use toString, now I have a point, and this point contains the latitude and longitude. And what I can do is I can leverage something called the OpenStreetMap. So I'm going to show you all that. And I can basically come in and paste in that point value. And sure enough, let's see where it is. If I zoom out, we can see that this is very close. This is in Seattle, Bellevue, Washington area, and it's very close to Microsoft's campus. So here's where that one bus point is located. All right, so storing locations, we can see is supported very easily in Azure SQL Database. But what else can we do? So one thing you can do is you can use these functions, for example, stDistance, which is basically going to say what's the distance between bus 1 and bus 2, so those two vehicle IDs, and we can see in meters what the result is. Now, for our specific example, what we have is this idea of a geofence. So a geofence is more like a polygon. So let's say I am trying to catch the bus from somewhere, here we want to do polygon. Let's say I'm trying to catch the bus from somewhere in this geofence. So when the bus comes here, let's say maybe I work nearby, I can get a notification when a bus is in the geofence. So in this case, this bus is in this geofence. And what you can see is we actually, instead of having a point, we have a polygon. So this is the polygon that represents this area. So if I go back here, one thing that might be interesting is to basically store that geofence in the database. So what I can use is geography and then this stgeom from text to basically take in that polygon and store it as a location. Now, similar to the point, it stores it in this binary format, but we can then convert that again using like toString like we did before. Now that we have a few points and a geofence, what we can do is we can use functions like stwithin to figure out if a point or a vehicle location is within a geofence. And then we can return something like a 1 if it is, or a 0 if it isn't. So just to confirm, we can check, and geometry collection just means it combines a point and a polygon. I'm just going to paste that in, and I can see this one. Here's the bus, and here's the geofence. And we can say, yes, it is in the geofence. And in fact, Azure SQL Database agrees with us. And same for this point, just for completeness, we can plot this, and we can see that this bus is out here, so it's not in the geofence. And Azure SQL Database also agrees. Okay, so now that we know Azure SQL Database can support the scenario, we can do things like create stored procedures to get and add data, but we actually don't have to run this because using GitHub Actions, we've automatically deployed that schema already to the database. So that's kind of the first step. So let me hop back to the slides, make sure I showed you all everything I wanted to show you. So we talked about configuring your environment, deploying Azure SQL Database, using GitHub Actions, importing the route data, and exploring JSON and geospatial support. So we've seen a lot, and this is the architecture that we're currently kind of dealing with. So you see we have buses, And those buses have some sort of IoT devices in them that's kind of transmitting this JSON data. Now, we're not concerned so much with how it's happening. We just know that this JSON data exists. And then we also took the route reference data, we put it in Azure Storage, and then we used T-SQL to import that data into Azure SQL database. Now, the next piece we're kind of missing is how we're going to get this real-time data into Azure SQL database. And that's kind of where this next module comes into play. So we're going to be talking about serverless APIs. So when it comes to selecting an API service, we go back to our requirements. We need a website for monitoring the real-time bus locations. We need notifications when a bus is close by, and we want deployment automation. We also, specifically for the API, we want to be able to get the latest data and identify buses in monitored routes and geofences. So I'm saying activations here because we basically want to know when it enters a geofence and when it exits a geofence. If it stays in a geofence, we don't necessarily need to be informed of that. And we talked about notifications, so we want to send an email notification for each bus that is activated. Now for this, sorry about that. For this, what we want to do is, I think we want to use Azure Functions. So Azure Functions are really great because they are serverless APIs. They scale on demand. There's no real difficult configuration to them. They also have a lot of great support in extensions and tooling and things like VS Code. So they're very easy to develop and work with locally before you deploy them, which is something I always find useful. And they support different triggers. So you can see some of the triggers. You can make an HTTP trigger, which we'll see later today. But really what we want for this is a timer trigger. So our goal initially for the Azure Functions is every 15 seconds, we want to determine what the monitor routes are. So we want to go up and figure out from what the user has told us what routes they're monitoring. Then we'll make an API call to get the latest JSON data that contains the latest bus information. We'll identify buses in monitored routes and activating a geofence, which we can leverage Azure SQL Database for once they're in Azure SQL Database. And then the final thing is we need to send an email notification for each activated bus. All these things that we can do with Azure Functions and Azure SQL Database. But for that last one, we could code up something that, wrote an email notification for each activated bus. But I thought it would be much easier to use Azure Logic Apps. Now, Azure Logic Apps are essentially a no-code development platform. They have a drag and drop interface, super easy to use, also serverless, and helps you integrate a bunch of different systems together. There are hundreds of connectors. So you'll just see a few connectors today, but you should know there are also a bunch of connectors for SQL Server, Azure SQL, Outlook, SMS, messages, file shares, Salesforce, other services all over the place, Gmail, calling. So let's take a look and see these Azure Functions in action. So I'm going to hop over to Visual Studio Code. Here it is. So I'm going to hop over to Visual Studio Code, and I'm going to show you, this is the GitHub repository associated with the stuff I'm going through today. And for the Azure Function, you can see that there's a .NET, a Node, and a Python folder. And that's because we wrote this sample in 3 different languages. Now, I'm going to start by showing you all .NET, and then we'll switch around. But what you can see is it's a very simple function. It's called getBusData. It runs every 15 seconds, so it's a timer trigger. And it simply just runs the process bus data. So if I go over here, what you can see briefly is what it's going to do is first it's going to get the real-time feed. So it's going to call out that JSON document and return in the latest bus data. It's going to get the monitored routes, and then it's going to see where the intersection is. So you only want to look for monitored routes. You don't want to look at all of them, because if I'm trying to go to A to B, I don't need to know how to go, somewhere else to somewhere else. That's not necessarily interesting to a user. So once we get the real-time feed, we get the monitored routes, which we're using from a stored procedure in Azure SQL Database. So you can see we're just making a connection to the database and then processing the results. And then we're going to process the geofence. So we're going to take in all that data and we're going to add it. And then we're going to use this other sort of procedure called add bus data, which basically works like you saw earlier. So it takes in that payload and stores it in a table in the Azure SQL database. And finally, it's going to trigger a logic app if it returns as something activating the geofence. So it'll essentially send two pieces of information to the logic app, the vehicle ID, so they know what route, and the status. So if it's entering or exiting a geofence. And yeah, so it's pretty simple. So what I can do is I can actually run this locally using something called func start. So this is, again, part of the extensions and the Azure Functions core tools that if you configure your environment, you can use very easily. So you can see it's restoring the project, and we're going to hopefully get that running. We'll just give it a few seconds to kick off, but you can see it's picking up the timer trigger get bus data, and then it's going to go ahead and every 15 seconds start polling the database. Now, typically you want to make sure this works locally, and you can see here it is receiving 525 buses. It found 3 buses in the monitored routes, but it found 0 buses activating a geofence. So I know it works locally. So now it's a lot easier to debug in this local state before I deploy it. So for now, I'm going to go ahead and stop that. I'm going to switch back over to the Azure portal, where you'll see I do have, here we go. I do have an Azure function app. So I've already gone ahead and deployed it. I've actually deployed this one using Python, but it has the exact same functionality. And you can see in the log, if I scroll down, you can see the exact same thing, the same results that we're seeing. So the bus positions, the ones that are in monitor routes, so on and so forth. Now, when a bus is activating a geofence, unfortunately, none seem to be activating at this moment. What it's going to do is it's going to trigger the logic app. So I mentioned that briefly. So when an HTTP request is received here, remember I said it needs to send 2 values, the vehicle ID and if it's entering or exiting the geofence. So when that happens, it's going to send an email. So you can see it's even parameterized. It says if you would like to catch the bus, you should head to the bus stop now. Your bus and then the route is entering or exiting the geofence. And you can set up who to send that to. You could even add more parameters here if you had different users that you wanted to send emails to. And we can see that in the process of me kind of going through this, you can see some buses have entered and exited the geofence. So that's cool to see it all working. Oh, one other thing I didn't show you is just like GitHub Actions were used for the Azure SQL database, they were also used for the Python function. So if I take a look at the template that we have here, you can see that it's going to be similar to the Azure SQL action, except it's a Python action. So it'll set up Python, and then it will use the Azure Functions action to actually deploy that, redeploy that to the Azure function. And just like before, we can store our secrets in the repository to connect to that Azure Function app. And you can see in GitHub Actions, if I go back to Actions over here, you can see for the Azure Function app some historical ones that show you how that, it goes through and installs the Python dependencies, and then it runs the Azure Function action. We got some warnings there I might need to check into later. All right, so now we've seen a lot of things, how to run Azure Functions locally, configuring CI/CD with GitHub, pushing notifications from the logic apps. You even saw some of those emails come through and you were able to monitor. And I want to try something different. So I'm going to do a knowledge check. We're going to go really fast. I just want to use this to kind of help you engage with me. And if you want to put in the chat or the Q&A what you think the answer to the question is, great. If you don't want to, that's okay too. Just think in your head about what you think the answer is. We're going to go really fast. So which service or services will be used to process real-time data and identify if a bus is within a geofence? So maybe this is tricky, maybe it isn't. The key is the services, because really we're going to be using a combination of Azure Functions and Azure SQL Database, because Azure Functions will go get the latest real-time data and then send it to Azure SQL Database, which will then return whether or not the bus is within a geofence. All right, so let's look again at the architecture that we have so far. We're just adding little pieces to it. In this section, we added Azure Functions with an Azure Logic app, which is sending a notification via Outlook. Now, the next thing we're going to have to do is figure out the application hosting service. So that leads us nicely into the third part of this, where we're going to be talking about building full stack applications with Azure Static Web Apps and Azure SQL Database. So I'm going to hop back to our requirements, right? Again, our overall solution requirements, we want a website for monitoring real-time bus locations. That is something we do not have yet. We want notifications when a bus is close by. We do have that. And we want deployment automation for all the pieces of the solution. Now, for the web application specifically, we want this website to display a map with real-time buses and geofences. And we want to somehow be able to filter on bus routes and geofences, because we don't want to monitor all of the bus routes or all of the geofences for all of our users of the app, just one geofence at a time. So for this, we can use something called a static web apps. Now, these are becoming increasingly popular, and they're basically built using things like Angular, React, Vue, Blazor. And the key thing here is that server-side rendering is not required. Now, for me, I'm kind of new to all this, and I worked with Davide, and we decided to use Vue for this, just to try something out. We've been hearing a lot about Vue. So that's a static web app, but what about the hosting? For this, we decided to use Azure Static Web Apps, and these are really cool because it essentially combines the power of static web application hosting with Azure Functions. So what you can see here is you can leverage either GitHub Actions or Azure DevOps to push from one repository static content, and also to leverage APIs behind that. So for example, if you need to make an HTTP request from your application, you can leverage Azure Functions to do that from within the same repo. Now, something cool about GitHub Actions, Azure DevOps, and Azure Static Web Apps is kind of different from Azure SQL Database and Azure Functions, where you have to create this template YAML file, which is going to be the instructions for your CI/CD. Azure Static Web Apps and GitHub Actions have a tight integration. So if you deploy this in the portal, you're actually going to give access to Azure, give access from Azure to your GitHub repository. So GitHub can actually Azure can actually create the YAML file for you, as well as creating the secrets. Now, before we had to create the secrets manually, but remember that the secrets are not stored in plain text. These are stored as tokens and secrets in the repository. And you can see it's also grabbing a GitHub token. Now, even if you deploy using, for example, the Azure CLI, it's still going to go through creating this for you. The only thing that you really have to do here is just tell the YAML file where your application and API are located within your repository. So for example, here we have our front end in the client folder, and here we have our API or Azure function being used in the API folder. So you have to tell it where those folders are located. All right, so again, we're going to do a quick knowledge check to see how you all are tracking. Again, we'll just go really quick through this. Feel free to put it in the chat or the Q&A, or just think to yourself. So what is the main value prop of Azure Static Web Apps? So the options are A, scalable cloud service for web apps that require server-side rendering. This is not correct, because remember we said it's for static web applications that do not require server-side rendering. This says variation of Azure Functions. Not really. It's not a variation of Azure Functions. It's really much more than that. C, combination of Azure Functions and Azure SQL Database. This is also not true, because we didn't talk about Azure SQL Database here. But the correct answer is D. That kind of leads us there. combination of static web apps and serverless APIs. All right, so the last question for this section, I promise, is what information is contained in the GitHub workflow file, so that YAML file, for an Azure Static Web Application? So it says app location and API location in the repository. So this is technically correct. So let's keep A. B says app location, API location, and secrets stored in plain text. That's not quite right. C says app location, API location, and references to secrets. Remember, I did say that it will create those references to secrets for you. So even though A is right, C is more correct because that information is also contained. And just to rule out D, your subscription ID is not contained anywhere inside the GitHub workflow file. All right, so let's do another demo and let's take a look. Let's just go deploy this thing. So what I'm gonna do is head over here. So hopefully you all can see this, and I'm also going to grab a new portal window. So let's do this. Bear with me. We're going to put the instructions over here and the portal over here, just because there's some references and it'll be useful to have them all together. And this is how you can actually go through the exercises. So you can just put them side by side and do things like look for static web apps. So you can see the services there, but you actually want to select from the marketplace because that allows you to create a new one. And then it's going to take us into this creation workflow. We're going to use my bus resource group, and we'll just call this bus app. That's available in my resource group. Yep, you can see there's only 2 pricing tiers, so it's very easy. We're just going to use free. We're going to use the location closest to me. We'll use WestUS, and we'll use GitHub. Oh, I always do this. Give me 1 second. For whatever reason, I default into the preview Azure portal, but I need to show you all the public Azure portal. So let me just get this back up. It will just take a second. And if you missed anything, now you'll get to see how to do it again. So I'm going to, again, select my bus resource group. I'm going to name this bus app. We're going to use free. We're going to pick the region closest to us, and we're going to sign in with GitHub. So remember, I was saying you'll actually give Azure access to kind of help with your GitHub repository. So let me type in my password, hopefully correctly. And now once I'm authenticated, I can select my repository. So that's my GitHub account. I can select, what was this one? Serverless, full stack apps. And I can even select the branch in that GitHub repository. And then I can give Azure a hint at what I'm using. So I'm using the Vue framework, but you can see there are other options here. And then these are the things I told you. Remember, you're going to have to tell it is the app location and API location. Now, when you're doing these exercises, make sure you use the right language at the beginning because it does vary slightly. So we're using Python. So, oh, here it is. App location, we want to enter this. And for API, we'll use this one because we're using the Python built-in function. But again, remember, we did do this for .NET and Node as well. So you can do either of those. Now I'm going to hit review and create. And once that validates, I'll go ahead and kick off the deployment. So while this is deploying, let's just go back and talk about what this front-end application is actually going to do, and how are we going to access the data to surface it in Azure Static Web Apps. So here's a little diagram to kind of help with that. If we focus on what we're trying to do for the front end, is we're basically trying to call the back-end API that will then return the data, in this case, the geospatial data that we want to surface in the application. Now that backend API is then going to call Azure SQL Database, which is then going to bring it forward to the backend, which we can then use to push to the front end. So if we think about the data for the front end, one of our requirements was to be able to include the geofence ID and a route ID. So we're not, searching for all of them. So what we're going to do is in the URL, we're going to include the route ID and the geofence ID, just like you see here. And then for the front end, we're going to parse that to get the route ID and geofence ID. And we're going to use that information to then call the API URL. And remember, that API URL basically is going to call Azure SQL, is going to call a stored procedure in Azure SQL that returns the data to be surfaced in the front end. Now, when you call Azure SQL database from your application, something important to keep in mind is that depending on the language you're using, there's a different library or a different package you can use. You can see for .NET, Python, and Node, for example, there are different packages you can use. And something to not get tricked up by is that there are also different formats of the connection string required. So you can see, depending on the language, you have to format your connection string differently. I know this sounds obvious, but I've gotten stuck quite a few times, and I've seen other people get stuck where, you're using .NET, but you're using the Python way of connecting, so it doesn't work. So something to be aware of. And just to add briefly to that, pretty much every language we have packages, and there are packages available for making it very easy and resilient to connect to Azure SQL database. All right, so basically what that API is doing is it's calling web get monitored bus data, stored procedure, and it's going to return these 2 points in JSON, the bus data and the geofence data. So we're going to be able to plot all the different buses that have been recently close by, and we're going to plot all the geofences, or in this case, just one geofence. Now, since we can specify how to return this information, it makes it super easy to process it in our application. All right, so before we take a look at a demo, again, just 2 more questions. I think these are the last 2 questions of the session. So you're in the clear if this was not something you were a big fan of, but think about these questions. So the first question is, what do the RID and GID parameters represent? So hopefully you've had a few seconds to kind of look this over, but basically the RID is the route ID, so it's a very specific route, and the GID is the geofence ID, and those are the ones that we want to be displayed on our site or our application for a given user. So the answer for this is A. Now, the second question, or I guess the 5th question, the final question, is a little more complicated, but the question asks, what is the order of serving data to the front end? So I'm basically trying to quiz if you understand how the client application is going to call Azure Functions, which is then going to call Azure SQL Database, and then return that forward. Now, again, you can pause if you need a little more time to answer, but the answer for this is C. So the client application is going to obtain the parameters and pass them to the Azure function. And then the Azure function is going to get the relevant data from Azure SQL Database using that stored procedure. And then it's going to return that to the Azure function, which will pass it to the front end application. All right, so now that you've kind of seen it all and heard about it all, let's revisit the application, and hopefully it's deployed already, and kind of look at what happened. So I'm going to hop to Visual Studio Code again. And now what you're seeing, we already looked at the Azure function, but now we can look at the Azure Static Web App, and we can see there's 2 folders in here. The client, so this is our front end. And if we look at our front end, let me just close some of this. If we look at our front end, we can see we're using a template from an open source site, which you can look more into. But basically, all we're going to do is we're going to get the RID and GID, which you saw earlier, and then we're going to use that information to call the API URL. And then once we get the results from the API, we're going to plot that data. So we're taking in the data, and we're going to plot the geofence, we're going to plot the bus data, and you can see the standards that we're adhering to here. So very simple front-end application. Now for the back end, you see there's multiple languages here. We're actually using Python for this one. So if we click into here, what you can see is we're also going to be taking in those RID and GID, because remember, we require those. And then we're simply going to open up a connection to Azure SQL Database. In this case, we're using PyODBC. because that's the package we're using in Python. And we're going to execute the stored procedure, which returns with the parameters of route ID and geofence ID. And then we're going to return the result. And we're essentially going to return the result. And that's what's being passed back. Oops. That's what's being passed to that client application. When the result comes back, you can see we're going to get the data as a result, and we're going to plot that data. Now, if we hop back to the Azure portal, what we can see is that this application did deploy, or our static web app. So if we go take a look at it, while it's loading, what we can see is a few things down here. Let me make that a little bigger. So we can see my resource group. We can see the URL for the application. We can see the source for GitHub and the GitHub action runs, because again, this is very integrated with GitHub Actions, which makes it easy. So if we go over to the GitHub action runs, we can see that this run completed recently. Let's see, yeah, for the Azure Static Web Apps. And we can see what it did and how it was a little bit easier because we didn't have to go through creating this template. This just got created for us. So it found the app location, it found the API location, and then it was able to identify that this was a Python function, and it went and got all the requirements for the Python function, and then it went through building up the application and the API. So really cool how all this works and how it's integrated with GitHub so easily. You can even edit the workflow from here. You can see some other information. Now, if we go take a look at the application, what we're going to see is we're going to see the map, but we don't see any data points on the map. And the reason for this is all we did was deploy it connected to our repository, but we didn't tell it how to access Azure SQL Database. So for that, it's very easy. We can go into the application settings, and I can grab the connection string. Again, remember, I have to make sure I grab the Python connection string here because that's what I'm using. And we'll just come in here. We'll say Azure SQL connection string and give it the value. And we'll hit OK. And we'll go ahead and save that connection string. So now if we come back to the application and we refresh, we still don't see anything. Now, I'll give you a second to think about why we don't see anything. A hint is what's going on in the URL. But the reason is we haven't specified the route ID and geofence ID. So now that we've specified that, what you can see is, sure enough, we're able to connect to the Azure SQL Database. We see some buses recently. Let's see where our geofence is. Okay, so our geofence is down here. So we can see that there are a few buses on the way to the geofence, but none that are exactly close by. But now we have a website where we can monitor this. We've also set up the notifications. So that's kind of all here. And we were able to get this all set up with GitHub Actions using Azure Static Web App. So really cool stuff, really easy, really fast to get set up. So hopefully that was a little interesting. All right, so what did we do? We configured the application. We looked at the published application and we reviewed the GitHub action run. Now, this brings us to the solution architecture that we have now put together. So let's briefly review. First, we have the buses, which have some sort of IoT device, which is regularly pushing up to this JSON document, which contains all the real-time bus information. Now, we're using an Azure function to call this every 15 seconds and then bring that data into Azure SQL Database. In addition to bringing the data into Azure SQL Database, it's going to leverage a stored procedure to find out if any of the buses are entering or exiting a given geofence. If they are, the Azure function is going to trigger the Azure Logic app, which is using the Outlook connector to then send an email that contains the route information and if the bus is entering or exiting the geofence. Pretty cool so far. What we also had done at the very beginning is we imported the route reference data using T-SQL and an Azure Storage account into Azure SQL Database. That helps with this process as well. Now, the most recent thing that we added was the Azure Static Web App, which contains an Azure function. So it also uses GitHub Actions. Again, you could alternatively use Azure DevOps here. But what it does is it uses GitHub Actions to push any changes for the application or the API. And the API calls Azure SQL Database to return all the monitored route bus data for a given route ID and geofence ID. And then those results are surfaced in an Azure Static Web App, which results in the website for monitoring active buses for our users. So this architecture uses several different services to minimize the amount of code you were using to write, and we're using different services for multiple purposes. So you could call this like a microservices approach, but what's cool is we wrote the application in Vue, we wrote this Azure function in Python and this Azure function in Python, but if you wanted to, you could actually write one of them in Python and one of them in Node. So this means if you're working in teams and some people are more comfortable with one language over another, this architecture is going to allow you to kind of do that and maybe get stuff out of the door faster because of this. And remember, all of this is being hosted on a serverless database, which is going to auto scale on a per second basis to meet the requirements of the workload being put on the database. So if a lot of people are using this application and we're hitting this database a lot, then it will go up in scale and scale to the number of vCores that we need at that time. And then if no one's using the application, it can even go into a pause state, which can help us save costs. All right, so let's summarize. We covered a lot in not a ton of time. But basically what you saw is how in the language of your choice, you can use an Azure function built into an Azure Static Web App to get data for specific bus routes and geofences. And this information was then used, that's stored in Azure SQL Database, to surface the map information on a website and send notifications using Azure Logic Apps. So you learned how to design APIs and integrate them with things like Azure SQL Database and Azure Static Web Apps. You learned a bit about Vue. You could go take a closer look at the code sample to learn more about it. We saw how to use Visual Studio Code, SQL Notebooks in Azure Data Studio, the Azure Portal, GitHub. We learned how to use all these tools together, how to set them up for success to run locally. Oh, by the way, you can also run Azure Static Web Apps locally. We only got to show you how to run functions locally, but you can also run Azure Static Web Apps locally before you deploy them. And we saw for Azure SQL Database, for Azure Functions, and for Azure Static Web Apps, how you can leverage CI/CD using GitHub Actions. So a bunch of resources for you, but the main one I hope you'll check out is this first one, aka.ms/Azure Modern Apps. Now, just a reminder, that's going to take you to, let me grab it. If you go to aka.ms/Azure Modern Apps, that's going to take you to the learning path, which has 4 modules. Now, you don't have to perform these modules in order. You could choose to only do the one focused on Azure SQL Database. You could choose to only do the one focused on GitHub. If you're really committed, I would recommend going through all of them because they each focus on different pieces of the solution. But again, do what you need to do. The code sample is out there as well. So even if you go into any of these, you're going to see how to get the code sample. Let's see. Code sample is here. Sorry about that. So here's the code sample. You can do what I did and fork it, and then you're going to have access to the DACPack file, the Azure Static Web App code, the Azure Function code. Remember, these things are all in 3 different languages, so I hope you'll try this out, fork it. I would even challenge you to try to create it for your own city and let me know. We showed you for Seattle, King County metro area, but many big cities actually post this real-time data. So I think it might be pretty interesting to port it to a city near you. Another action is to potentially follow us on our YouTube show, or I guess subscribe to our YouTube channel is the right thing to say there. But what you can see is we have new episodes we release every Thursday. We also stream live on Wednesdays, and we also have members of the MVP community on the show. So that's a great way to learn and stay up to date. You can also follow us on Twitter. And we wrote a book. Myself, Davide, and a few other PMs on the team wrote a book called Practical Azure SQL Database for Modern Developers. So if you want to dive deeper into this topic, I definitely recommend checking that out. I mentioned that we stream every Wednesday. We stream to YouTube, Twitter, Twitch, but we also stream to Learn TV, which is Microsoft's 24-hour news station. So that's another thing to definitely go check out. I really appreciate all you all's time for coming here and meeting with us. Again, I want to thank the sponsors, want to thank DPS for the opportunity and the ability to get in front of you guys virtually. I know this virtual world has been tough, and I'm really hoping that sometime soon I can see all of you in person. In the meantime, I hope you enjoy the rest of the conference. I am around if you have any questions, so please ask your questions. And I just want to thank you again for taking the time, and I hope you enjoy the rest of the summit.